Good afternoon. Welcome to this session on the electric grid. As Munder said, my name is Bob Armstrong. I'm director of the MIT Energy Initiative. And I'm going to be moderating this panel which looks at the future electric grid. As many of you probably know, there's a strong correlation that's well known between electricity consumption per capita and a human development index. So electricity is core to our quality of life globally. At the same time, there are, at this point, about 1.2 billion people on the planet who don't have access to electricity at all. If you look at a country like India, India has about 400 million people in its population without access to electricity. By 2050, there will be 400 million more people in India based on population projections. So one country alone, between now and 2050, we have a task of getting electricity to 800 million people who don't have it at this point. The electrical grid has been a key to delivering electricity to people and to enabling this development of quality of life, particularly in the developed world. The electric grid's a marvelous thing. The National Academy of Engineering in the U.S., in fact, recognized the electric grid as one of the, in fact, the first among the 20 great engineering achievements of the 20th century. So it's a real marvel of engineering that you can, at any one time, balance the loads on the system with the generation that's going on the system. In fact, I've heard the electric grid described as the world's largest supply chain with no inventory. Right? So it's a really tough problem to do. At the same time, we know that we look at the electric grid and the delivery of electricity to people who don't have it in the context of global warming. Climate change is perhaps the most serious issue we face as a global society. 2016 is on track to be the warmest year on record. That's one in a long series of records we've been setting lately. So clearly, in addition to increasing the supply of electricity to people who don't have it, we need to decarbonize the energy system globally. So it's a dual challenge that we face, and that makes it particularly difficult. The electric power system is a particularly attractive first target for decarbonization because much of the generation is done centrally, and so we can go after decarbonizing at large point sources rather than, for example, in transportation, having to go after decarbonizing from distributed sources of emissions. So this is a great opportunity for us both to improve quality of life and to decarbonize the system. A lot of challenges that we want to hit on today on this panel, and I think the panelists will cover these and stimulate a lot of thinking in the audience about what are issues in deploying more electricity, more decarbonized electricity in developing versus developed countries. What about the challenges of distributed versus centralized generation or other energy resources? It could be storage, for example. What about electrification of transportation? What does that do to the behavior of the grid and our electric power system? We have enhanced data capabilities in our electricity system. We know a lot about what consumers are doing. They can interact with energy suppliers. How might that help us achieve the goals we want to achieve? Interesting challenges for markets and regulatory regimes going forward. How do we put in regulatory systems that can incentivize industry to deliver these services that we need? Lots of different challenges facing us, but huge opportunity in front of us. So we'd like in the panel to begin with Professor Michael Greenstone from the University of Chicago. He's going to address some of the challenges in the developing world in particular and challenges in what can happen depending on how we generate our electricity. Professor Sally Benson from Stanford University will follow, looking at home-scale grids and understanding sort of a data-rich environment and what we can do there. Stephen Lowe from Caltech, Professor Stephen Lowe, will look at the power system structure of and architecture of the grid, power electronics, issues like that. And then finally, Professor Bill Hogan from Harvard University will look at markets and regulatory environments. So with that, let me turn it over to Michael Greenstone.